November 20th, 1944. 28,000 feet above the German countryside near Merseburg, First Lieutenant Robert Johnson rolled his Republic P-47 Thunderbolt into a dive that violated every rule of high-altitude combat written in the Army Air Force's fighter manual. Below him, a formation of Focke-Wulf 190 fighters climbed desperately to intercept American bombers, unaware that 7 tons of American steel was plummeting toward them at a speed that would shatter every conception of what a fighter aircraft could achieve. What Johnson was about to demonstrate would redefine the tactical possibilities of American fighter operations over Europe. The P-47 Thunderbolt, ridiculed by pilots as too heavy and too slow for air combat, was about to become a 500-mile-per-hour missile that would terrorize German fighter pilots for the remainder of the war. This dive would prove that weight, when properly applied, could become the ultimate weapon in aerial warfare. 600 miles per hour. Johnson's Thunderbolt exceeded the terminal velocity of falling aircraft as its massive radial engine pulled the 7-ton fighter through increasingly dense air. The airspeed indicator passed readings that Republic aviation engineers had declared structurally impossible. Control surfaces that should have locked solid at such speeds remained responsive. The aircraft that German pilots dismissed as a lumbering heavyweight was demonstrating performance that defied fundamental assumptions about fighter aircraft capabilities. This was the moment when American fighter doctrine began its transformation from European-style turning combat to high-speed slashing attacks that exploited American industrial advantages. The P-47's massive weight, initially considered a liability, became its greatest tactical asset when combined with the crushing power of gravity and the structural strength that only American manufacturing could achieve. The story of how the Republic P-47 Thunderbolt evolved from an unwanted heavyweight into America's most feared fighter doesn't begin with tactical innovation. It begins with American engineering philosophy that prioritized firepower and survivability over European concepts of agility and speed. To understand why Johnson's suicidal dive represented such a revolutionary breakthrough, you must first understand what American fighters were designed to accomplish and why those design goals initially appeared to be catastrophic mistakes. In 1941, when the first P-47 prototypes emerged from Republic Aviation's Farmingdale factory, American fighter doctrine emphasized high-altitude interception of enemy bombers rather than air-to-air combat with enemy fighters. The Army Air Corps specification that created the Thunderbolt demanded an aircraft capable of climbing to 40,000 feet while carrying sufficient armament to destroy heavily defended German bombers with a single attack. Alexander Kartveli, chief designer at Republic Aviation, approached the Army requirement with engineering principles that differed fundamentally from European fighter philosophy. While British and German designers pursued minimum weight and maximum agility, Kartveli embraced mass and structural strength as the foundations of combat effectiveness. His philosophy assumed that American industrial capacity could produce fighters too strong to be shot down and too heavily armed to require prolonged engagement. The Pratt & Whitney R2 1800 double wasp engine that powered the P-47 represented American powerplant philosophy taken to its logical extreme. The 18-cylinder radial engine displaced 2,800 cubic inches and produced over 2,000 horsepower at takeoff. No European engine approached the massive power output or the structural robustness that American manufacturing techniques made possible. The engine installation required a fuselage large enough to accommodate the massive power plant and its associated cooling systems. The P-47's fuselage measured 24 feet in length and weighed more than most complete European fighters. German pilots observing early P-47 operations nicknamed the aircraft the bathtub due to its enormous size and apparent ungainliness in flight. Armament philosophy reflected similar American preferences for overwhelming firepower over surgical precision. The P-47 carried 8 50-caliber machine guns with over 3,000 rounds of ammunition. The concentrated firepower exceeded that of any fighter aircraft in service with any air force. German pilots who survived P-47 attacks described the experience as flying into a wall of steel that destroyed aircraft instantly. The structural design incorporated safety factors that exceeded normal aircraft engineering standards by enormous margins. Republic engineers designed the P-47 to withstand stresses that would destroy conventional fighters. The massive internal structure included redundant control systems, self-sealing fuel tanks, and pilot protection that enabled survival under combat conditions that would prove fatal in lighter aircraft. Early operational testing revealed performance characteristics that appeared to confirm European criticisms of American design philosophy. The P-47 climbed slowly compared to British and German fighters. Initial acceleration proved sluggish. Turning radius at combat speeds exceeded that of any contemporary fighter aircraft. Army Air Force's test pilots filed reports questioning whether the aircraft possessed any useful combat capabilities. The first P-47 squadrons to reach European combat theaters in early 1943 encountered immediate tactical problems that reinforced doubts about American fighter design. German Messerschmitt Bf-109 and Focke-Wulf FW-190 fighters consistently outmaneuvered American formations using traditional European combat tactics. P-47 losses mounted rapidly as American pilots attempted to engage German fighters in turning combat. The initial combat experiences of American P-47 pilots in the European theater of operations revealed fundamental mismatches between aircraft capabilities and tactical employment that threatened to undermine the entire American fighter program. Lieutenant Colonel Armin Peterson, commanding the 56th Fighter Group during its first combat operations, filed reports expressing serious concerns about P-47's suitability for air-to-air combat against experienced German opponents. Major Gerald Johnson, leading the 63rd Fighter Squadron during early missions over occupied France, discovered that his P-47 could not sustain turning engagements with German fighters at any altitude or airspeed. German pilots exploited American aircraft limitations by forcing sustained horizontal maneuvering that played to Messerschmitt and Focke-Wulf advantages while negating P-47 strengths in firepower and structural durability. The psychological impact on American pilots proved as significant as the tactical disadvantages revealed through combat experience. Aircrew who had trained with confidence in their equipment's superiority found themselves consistently outmaneuvered by German opponents flying lighter, more agile aircraft. Pilot confidence eroded rapidly as casualty rates exceeded acceptable levels during the initial deployment period. Technical representatives from Republic Aviation arrived in England during spring 1943 to investigate combat performance problems and identify potential modifications that might improve P-47 effectiveness. However, the engineering analysis revealed that aircraft performance limitations reflected design philosophy rather than technical deficiencies that could be corrected through modifications. Colonel Hub Zemke, commanding the 56th Fighter Group, implemented training programs designed to exploit P-47 advantages while avoiding tactical situations that favored lighter European fighters. His pilots learned to use superior firepower and structural strength rather than attempting to match German agility. However, the learning curve proved steep, and casualties remained high throughout the initial combat period. The systematic analysis of P-47 combat performance, conducted by experienced American pilots, identified specific flight regimes where the heavyweight fighter demonstrated superior capabilities. High-speed flight at altitudes above 25,000 feet revealed performance characteristics that conventional tactical doctrine had not explored. The aircraft's massive weight and structural strength provided advantages that lighter fighters could not match. The breakthrough in P-47. Tactical employment came through systematic analysis of the aircraft's unique performance characteristics rather than attempts to make the fighter behave like lighter European designs. American engineers discovered that the P-47's massive weight provided decisive advantages in high-speed flight regimes, where lighter aircraft encountered structural limitations. The physics of high-speed dive performance involved complex interactions between aircraft weight, structural strength, and aerodynamic characteristics that favored robust American designs over lightweight European approaches. Mathematical analysis conducted by Republic Aviation engineers confirmed that P-47 diving performance exceeded theoretical limits for conventional fighter aircraft by significant margins. Wind tunnel testing conducted at the National Advisory Committee for Aeronautics Facilities provided scientific validation of P-47 high-speed capabilities that combat pilots had discovered through practical experience. The aerodynamic analysis revealed that the aircraft's design incorporated features that optimized performance in flight regimes that other fighters could not enter safely. Major Francis Gabreski, flying with the 61st Fighter Squadron, conducted unauthorized high-speed dive tests that revealed P-47 capabilities unknown to Republic's engineering staff. Gabreski's aircraft achieved speeds approaching 600 miles per hour in vertical dives, while maintaining structural integrity and control responsiveness. The performance exceeded anything achievable by German or British fighters. The test flights conducted by Gabreski involved systematic exploration of P-47 performance limits through carefully controlled dive profiles that pushed the aircraft beyond published specifications. His methodical approach to flight testing provided quantitative data on aircraft capabilities that had been theoretical until proven through actual flight operations under controlled conditions. The structural analysis of P-47 components following high-speed flight testing revealed engineering margins that exceeded normal aircraft design standards by enormous factors. Republic Aviation had incorporated safety factors that enabled the aircraft to sustain stresses that would destroy conventionally built fighters. The robust construction reflected American manufacturing capabilities that European industry could not match. Control system analysis demonstrated that P-47 flight controls remained responsive at airspeeds where conventional aircraft experienced control surface lockup and loss of maneuverability. The hydraulically boosted control systems incorporated design features that maintained pilot authority throughout the aircraft's operational envelope, including extreme high-speed flight conditions. The physics of high-speed dive performance favored massive aircraft with robust construction over lightweight designs optimized for turning combat. The P-47's weight accelerated the aircraft through dense air more effectively than lighter fighters could achieve. Structural strength prevented the control surface lockup and structural failures that limited dive performance in conventional aircraft. The aerodynamic characteristics of the P-47 at high speeds involved complex interactions between airflow patterns, structural flexibility, and control surface effectiveness that required advanced engineering analysis to understand completely. Republic Aviation's design team had unknowingly created an aircraft optimized for flight conditions that tactical doctrine had not previously considered relevant to fighter operations. Engine performance analysis revealed that the Pratt & Whitney R2800 double WASP maintained power output and reliability under high-speed conditions that would cause conventional engines to fail catastrophically. The massive radial engine incorporated cooling systems and structural features that enabled sustained operation under extreme stress conditions. Bob Johnson's combat experience during summer 1943 provided the tactical innovations that transformed P-47 employment from defensive missions to offensive operations. Johnson discovered that German fighters could not escape P-47 attacks initiated from high altitude with sufficient speed advantage. The combination of weight and power created tactical possibilities that no other aircraft could duplicate. Johnson's systematic approach to tactical development involved careful analysis of German fighter capabilities and limitations combined with methodical exploration of P-47 performance advantages. His combat experience provided practical insights that complemented theoretical analysis conducted by engineering personnel. The integration of pilot experience with technical knowledge produced tactical innovations that proved decisive. The development of high-speed attack techniques required exceptional pilot skill and situational awareness that exceeded normal fighter pilot training standards. Johnson's methods demanded precise timing, accurate target assessment, and split-second decision-making under combat conditions that allowed no margin for error. The tactical complexity required extensive training and exceptional pilot capability. Combat evaluation of different attack profiles, conducted through actual engagements with German fighters, provided quantitative assessment of tactical effectiveness under varying conditions. Johnson's methodical approach to combat testing enabled systematic refinement of attack procedures that maximized P-47 advantages while minimizing exposure to German defensive capabilities. Johnson's first successful high-speed attack occurred during a bomber escort mission over northern France in August 1943. Observing German fighters climbing to intercept American bombers, Johnson positioned his P-47 8,000 feet above the enemy formation and rolled into a dive that accelerated his aircraft beyond 500 miles per hour. The attacking German fighters had no opportunity to evade before Johnson's 8 machine guns destroyed the lead aircraft. The engagement sequence that led to Johnson's breakthrough attack involved careful observation of German tactical procedures and identification of specific vulnerabilities that could be exploited through high-speed approaches. German fighter formations climbing to intercept bombers presented ideal targets for diving attacks that German pilots could not anticipate or counter effectively. The gunnery techniques required for successful high-speed attacks differed significantly from conventional fighter armament employment methods. Johnson developed firing procedures that compensated for extreme closure rates and brief engagement windows while maximizing the effectiveness of 850 caliber machine guns. The concentrated firepower proved devastatingly effective when properly applied. Target selection criteria developed through combat experience enabled Johnson to identify optimal attack opportunities while avoiding engagements that favored German fighters. The systematic approach to tactical decision-making reflected professional analysis rather than opportunistic aggression. Johnson's methods could be taught to other pilots and replicated consistently. The tactical effectiveness of high-speed diving attacks depended on precise altitude management and target selection that required exceptional pilot skill and situational awareness. Johnson developed systematic procedures for identifying optimal attack opportunities and executing dives that maximized speed advantage while minimizing exposure to enemy defensive fire. The altitude management techniques pioneered by Johnson involved maintaining superior position relative to German formations while conserving aircraft energy for high-speed attacks. The procedures required constant assessment of tactical situation and careful positioning that enabled rapid transition from defensive patrol to offensive engagement. The complexity demanded exceptional pilot training and experience. Navigation and communication procedures developed for high-speed attack operations enabled coordination between multiple P-47 pilots conducting simultaneous attacks against German formations. The tactical coordination multiplied individual aircraft effectiveness while providing mutual support during high-risk combat operations. The procedures represented advances in fighter tactics that influenced subsequent air combat development. The energy management techniques pioneered by Johnson emphasized conservation of altitude and speed rather than traditional concepts of aerial maneuverability. P-47 pilots learned to fight in the vertical plane where their aircraft's weight provided advantages instead of the horizontal plane where lighter fighters retained superiority. The tactical revolution required completely different pilot training and operational procedures. The training programs developed to teach energy management techniques involved systematic instruction in physics principles that governed high-speed flight and tactical employment under various atmospheric conditions. Pilots learned to calculate energy states and predict aircraft performance under different combat scenarios. The scientific approach to fighter tactics represented unprecedented sophistication in military aviation training. German fighter pilots initially dismissed high-speed P-47 attacks as desperate maneuvers by inferior pilots flying inadequate aircraft. Luftwaffe intelligence reports described American tactics as unsustainable and ineffective against properly executed German defensive procedures. However, mounting German losses forced acknowledgement that American fighters had developed genuinely threatening tactical capabilities. The psychological impact on German pilots proved as significant as the tactical effectiveness of P-47 diving attacks. Luftwaffe aircrew discovered that no evasive maneuver could escape an American fighter diving at 600 miles per hour. The realization that German fighters could be destroyed by attacks they could neither prevent nor counter undermined confidence that had sustained German fighter operations since the beginning of the war. Hauptmann Georg Peter Eder, commanding the Truppengruppe of Jagdgeschwader 1, filed detailed reports describing P-47 attack characteristics that exceeded German understanding of fighter aircraft capabilities. Eder's technical analysis confirmed that American fighters achieved speeds in combat that German aircraft could not match under any circumstances. The performance advantage proved decisive in determining engagement outcomes. The industrial implications of P-47 tactical success extended beyond immediate combat effectiveness to influence German fighter development and production priorities. Luftwaffe requirements for improved climbing performance and enhanced defensive armament competed with other military needs for limited German manufacturing capacity. The resource allocation forced difficult choices that affected overall German war production. American P-47 production increased rapidly as combat success demonstrated the tactical value of the heavyweight fighter approach. Republic Aviation expanded manufacturing facilities throughout Long Island, while subcontractors across the United States contributed components and assemblies. The production coordination represented unprecedented industrial organization that German planners had not anticipated. Quality control procedures implemented throughout the P-47 production system ensured consistent aircraft performance, despite rapidly increasing manufacturing rates. American workers achieved precision standards that maintained structural integrity under combat stresses that would destroy conventionally built aircraft. The manufacturing excellence reflected industrial capabilities that German industry could not match. The evolution of P-47 variants throughout the war demonstrated systematic improvement of already superior performance characteristics. Later models incorporated more powerful engines, improved armament installations, and aerodynamic refinements that enhanced diving performance while maintaining the structural advantages that made high-speed attacks possible. The P-47D model, introduced in 1944, provided increased range and enhanced high-altitude performance that extended American tactical advantages to all operational altitudes. The improved aircraft enabled escort missions deep into German territory while maintaining the diving attack capabilities that had proven so effective against German fighters. Advanced pilot training programs developed specifically for P-47 operations taught American aircrew to exploit their aircraft's unique capabilities, while avoiding tactical situations that favored enemy fighters. The training emphasized energy management, high-speed gunnery, and tactical patience, rather than traditional dogfighting techniques that played to German strengths. Combat evaluation of P-47 effectiveness against German fighters provided quantitative assessment of tactical innovations pioneered by pilots like Bob Johnson. Statistical analysis of engagement outcomes confirmed that properly executed diving attacks achieved success rates exceeding 90% against German fighter formations. The tactical advantage proved decisive throughout the European air war. The strategic impact of P-47 operations extended beyond fighter-versus-fighter combat to influence the entire air campaign over Europe. German fighter forces committed to defending against American bomber formations found themselves under attack from escort fighters that could not be engaged successfully using traditional combat methods. The tactical situation forced fundamental changes in German defensive procedures. Luftwaffe fighter units attempted to counter P-47 diving attacks through modified tactics and improved aircraft performance. However, the fundamental physics of high-speed flight favored American aircraft with their superior weight and structural strength. German responses proved inadequate to restore the tactical balance that had favored European fighters during early war periods. The technological lessons learned from P-47 combat operations influenced American fighter development throughout the war and into the jet age. The principles of high-speed attack, structural robustness, and overwhelming firepower became fundamental characteristics of subsequent American fighter designs. The tactical innovations pioneered with the Thunderbolt established patterns that continue influencing military aviation. International recognition of P-47 capabilities led to export orders and technology transfer agreements that extended American tactical innovations to Allied air forces worldwide. British, Soviet, and Free French pilots operating American fighters adopted the high-speed attack techniques that had proven so effective against German aircraft. The tactical influence spread throughout Allied aviation. Post-war analysis of combat records confirmed that P-47 pilots achieved air-to-air victory ratios that exceeded those of any other American fighter aircraft. The statistical success reflected tactical advantages created by proper exploitation of aircraft characteristics rather than attempting to imitate European fighter employment methods. The lesson influenced post-war American military aviation development significantly. Bob Johnson's personal combat record included 28 confirmed aerial victories, achieved primarily through high-speed diving attacks that exploited P-47 performance advantages. His tactical innovations contributed directly to American air superiority over Europe and influenced fighter pilot training throughout the United States Army Air Forces. Johnson's methods became standard procedures taught to replacement pilots. The demonstration of P-47 diving capabilities at 600 miles per hour revolutionized American fighter tactics and proved that innovative employment of existing equipment could overcome apparent performance disadvantages. The aircraft that seemed unsuitable for air combat became one of the most effective fighters of World War II through tactical methods that exploited its unique characteristics. German fighter pilot memoirs written after the war consistently described P-47 diving attacks as the most feared threat encountered during combat operations over Europe. The psychological impact of facing unavoidable attacks by indestructible American fighters undermined German pilot morale and contributed to declining Luftwaffe effectiveness throughout the final years of the war. The engineering lessons learned from P-47 structural performance under extreme combat conditions influenced post-war American aircraft design philosophy. The demonstration that robust construction could provide tactical advantages led to continued emphasis on structural strength and survivability in subsequent military aircraft development programs. November 20, 1944. 28,000 feet above Merseburg. Bob Johnson's P-47 Thunderbolt plummeted toward the German formation at 600 miles per hour, transforming 7 tons of American steel into a precision-guided missile that would redefine fighter combat. The suicidal dive that violated every rule of aerial engagement had become the standard tactic that gave American fighters decisive superiority over European airspace. The tactical revolution was complete. What had begun as desperate improvisation by American pilots flying apparently inferior aircraft had evolved into systematic exploitation of unique performance characteristics that no other air force possessed. The P-47's massive weight, initially considered a fatal flaw, had become the weapon that enabled American fighters to dominate German formations throughout the European theater. The psychological transformation proved as significant as the tactical evolution. German pilots who had confidently engaged American formations during early war periods now avoided contact whenever possible. The appearance of P-47 formations overhead triggered immediate evasive actions by German fighters who understood that engagement meant probable destruction by attacks they could neither anticipate nor counter. Individual German pilots developed personal techniques for surviving encounters with diving P-47s, but no tactical response proved consistently effective against properly executed high-speed attacks. The fundamental physics of aerial combat favored American aircraft, when employed according to principles that Bob Johnson and other innovative pilots had discovered through combat experience. The strategic implications extended throughout the European Air War as German fighter effectiveness declined under pressure from American tactical innovations. Luftwaffe units committed to defending German airspace found themselves unable to prevent American bomber formations from reaching their targets, despite concentrated efforts to intercept Allied formations using traditional combat methods. The industrial lessons learned from P-47 combat success influenced American aircraft development throughout the war and into the jet age. The demonstration that innovative tactical employment could overcome apparent performance disadvantages established principles that continued guiding American military aviation development for decades after World War II ended. Post-war interviews with German fighter pilots consistently identified P-47 diving attacks as the most feared threat encountered during the European Air War. The psychological impact of facing unavoidable destruction by seemingly suicidal American attacks undermined German pilot confidence and contributed to declining Luftwaffe effectiveness during the final war years. The psychological transformation was complete. German pilots who had once confidently engaged any opponent now fled when American fighters appeared overhead. The heavy weight that had seemed like a mistake had become the weapon that broke German fighter resistance and contributed decisively to Allied victory in the air war over Europe. That's how one pilot's willingness to risk everything in a suicidal dive proved that American engineering philosophy could triumph over European tactical traditions through innovative employment of superior industrial capabilities. The P-47 Thunderbolt became proof that in aerial warfare, as in so many other endeavors, American approaches could succeed where conventional wisdom suggested only failure was possible.